Okay, good evening. I am Pain Tamlan from Northern Uni. So today I am going to explain about some interesting topic in our module wireless network technology. So first one, I am going to explain about important functions of ISO and OSI 7 layers. Right. So basically what is ISO and OSI means? That means the ISO means International Organization for Standard. Uh, sorry, the ISO means International Organization for Standardization. So that means it's an organization located in Switzerland. So they standardize some random or specific rules for some models or any tech related things. So uh, that is an organization, but the OSI model is uh, the open systems interconnection. That means in wireless technology, we have open system interconnection protocols. We have 7 layers also. So these organization standard the OSI models, right? So moving forward, so we have 7 layers in the OSI model. So we have physical and data link layer, network layer like that. So I'm going to start from the physical layer. Okay, right. So physical layers, what we'll do is the raw bit, it's transmit the raw bits of data. Okay, it deal with voltage levels and data rates. Okay, right. In physical layers, we use connectors and cables and all kind of things. Okay, right. The second one is data link layer. It's link the data with the physical layer. That means it's framing the bits. It's uh, frame the bits into frames. Sorry, it's turning the bits into frames. That means uh, we transmitting data into bits, so it uh, changing the data as a bits into frames. Okay, right. So it gives the physical address for our networking. Okay, right. In here we can do some error detection and flow control also. Right. Third layer is network layers. So in the network layers, we give some logical IP addresses. That means um, in one internet connection, or if we connect multiple devices, each devices have some network ID. That means in the network layer, we give IP address for each and every nodes. Okay, here we can do some routing also. Right. The fourth layer is transport layer. Okay, the transport layer, it's an end-to-end delivery, and then in here every layers connected with one another. Okay, in the specific task. Well, here mainly we are segmenting and reassemble the network. Okay, right. Right. Okay, here we have some session layer. That is a fifth layer. So we maintain some sessions for some what can I say? If anything happen, we are going to use that sessions to maintain the connection. Okay, so here we use some checkpoints to maintain our network connections, right? And another one, this OSI model is a theoretical one, not for the physical one or any uh, real world issue, but this is the theoretical models. Okay, so sixth is a presentation layer. So here we are doing some encryption and decryptions for the upcoming application layer, because we deal with zeros and ones, right? That is network transmitted into the uh, some encryption or decryption, or it's earlier I say the data transmitted into bits. Okay, but here we are going to encrypt or decrypt, that kind of things we are doing in the presentation layer. That means after these kind of things we can use it in the applications, right? This is the application layer. So it's an end application, the what the user use, yeah, what the user uses, we do in the application layer. That means it will create an interface. I mean, like our PC screens, it gives an interface between users and network. Okay, right. So in here we can do some data transfers or email and web access also, right? So we are using HTTP to browse some webs FTP for files and like that. Okay, right. So moving forward, we have some TCP IP also. That means uh, we had OSI model for the theoretical part, but here TCP IP is a practical one. So it's use the actual protocol for the internet, but uh, yeah, right. And also, and layers also, we have 7 layers in the OSI model, but in the TCP IP we have 4 or 5 layers, but usually we have 5 layers. Okay, right. Okay, this is the comparison between OSI and TCP IP. So we connect together 3 layers, application, presentation, and session into 1 layer in TCP/IP as application layer. Transport remain the same, and network also we are using the same. But in the TCP/IP, uh, in some diagrams we use as a internal layers, and then we combine the data link and physical into network interfaces. Right. We are used some protocols in TCP/IP. That means transport network and data link layers. Okay. We avoid the application layers. I think it's almost same, but here the transport network and network interface, we are using some protocols. Okay. Right. The first one is we are going with the transport layer protocols. So that means the first one is TCP, transmission control protocols. So, okay, right. It's basically connection oriented. So yeah, and then it's guarantee the delivery and preserve data order and transmits lost sequence also, right? In real application why we are browsing or internet or file transfers, we are using the TCP for continuous network specifications, right? Right. And then the second one, UDP, user datagram protocol. So this is also connectionless. That means, sorry, this is connectionless, but in the TCP models, it's connection oriented. Okay, right. So yeah, here uh, we are using video streaming, online gaming with the help of the UDP. That means uh, this will never produce some handshake or any retransmission or something. Okay, so right. And then it will extremely low latency. That means it's very fast. So it's especially we are using in the video gamings and online streamings, something like that. Right. And then the third one is network layer protocols. So it is the logical addressing, like I explained in the OSM model. So we heard something called IP address, that means internet protocols. Uh, the primary protocol we are using in the internet. Okay, so it will give logical address for each and every PC or mobiles when we are connecting with an particular network. So we can search with the terminal by using ipconfig in the Windows or ifconfig in the Linux-based system. We can get the IPv4 addresses, so we can check. Yeah, right. And then Internet Control Message Protocol. It's mainly used for the messaging, like sorry, yeah, messaging like that. Right, right. And also we have some ARP and RARP for some specific task, like uh, translate the IP into physical address, like means physical address, okay, like that. The other layer is data link protocol. Sorry, other protocol is data link protocols. It's focus physical addressing and local media access. Okay, right. It gives the more reliable way to uh, use our physical address and our LAN networks. Okay, yeah, right. And then Ethernet, we call it a IEEE 802.3, those standard for wired connections. So in every laboratories in the schools or and universities, we use LAN networks with a Ethernet protocol, right? And then Wi-Fi, we all heard about that. That means IEEE 802.11. We used Wi-Fi for the wireless communications, right? And then in some way we are also using point-to-point protocol. That means that we are using PPP or triple P. So it will do some direct connection between two nodes. That means we can connect two uh, particular uh, devices with some uh, one cable or something. I mean direct connection. There is no intermediation or something. So we call it as point-to-point. And then high level data link control, that means it's a bit oriented protocol for the PPP. Okay, right. That's all. Thank you so much.